A very good morning to all of you who are attending today's program. We are really happy that we have been invited by the National Council of Science Museums on this day, May 11th, the National Technology Day, to discuss on one of our innovation. Before I go to the topic proper, let me tell you that this activity, this particular innovation has been done by the team of Mechanical Engineering Department of NIT Durgapur and has been led by Professor Shibendu Shekhar, who is a co-speaker in this program, and I am from the discipline of computer science. As the head of the institute, I have tried to provide them with all sorts of support and guidance to the best of my ability, but the major design and development has been done by Professor Roy and his team. So I will just discuss with you for a few minutes and then we'll pass it on to Professor Roy, who will make the rest of the presentation. Now, before talking about the oxygen concentrators, let me just take this opportunity to discuss a very critical challenge that is associated with any technology. A technology is dependent, of course, on science and a number of social realities, the economic realities. So when we plan to make a low-cost product, we have to look at the components, the materials, which are combined together to give rise to a particular system. And in order that the system performance is at a very good level, each of these components and the materials have to be of very good quality. Now, the science, the physics or the chemistry remains the same, but these are some variants that really affect and challenge the technologists when we try to give a product. And obviously, when we try for low-cost products, we also have to compromise on minimize the imports and do a number of other technical tweaks and all those things. But at the same time, unless the material is of good quality, we cannot assure good performance. In India, there has been a lot of strides in technology, in information technology here, but we need a big support from material science, and we should have a good bunch of organizations who are providing materials of different kinds, ceramics, piezoelectrics, everything, so that our technology can be really reliable and quality. Now, the same challenge we are facing when we try to migrate from our lab prototype to a commercial product. Besides the quality and all the issues that I have discussed, the supply chain is also very important, the logistic support. You must need the components and the elements to arrive at your shop floor at the proper points of time. Now, coming to the particular topic that we are supposed to discuss, at NIT Durgapur we have tried to develop a low-cost oxygen concentrator. Why is that needed? Now you know, even when COVID was not there, a lot of people who suffer from respiratory problems, COPDs, and other pulmonary disorders often need to be supplemented by external supply of oxygen. Now, that external supply of oxygen in the hospital can come from a oxygen plant that is there, and there are pipelines laid all through the hospital to the patient beds where they can take the high flow oxygen. The next level is, of course, I am not talking of ventilators and BiPAP machines which are used at very critical points, which also pass on the oxygen through some separate methodology and technology, but the oxygen supply has to be there. Besides that oxygen plants, we also have big oxygen cylinders from which people can be given oxygen. Now, oxygen cylinders are usually heavy and often not portable enough. And that raised a challenge of having portable oxygen concentrators. The difference between concentrators and oxygen cylinders: oxygen cylinders are filled with oxygen before they are deployed. On the other hand, oxygen concentrators take the oxygen from natural air, and all of you know that air contains around 21% of oxygen, 78% of nitrogen, 0.04% of carbon dioxide, and 0.93% of argon and other trace gases, and of course water vapor. Now, out of this air, if I take that air through an inlet and churn out the oxygen from there and make it concentrated and deliver that concentrated oxygen through the nasal cannula or masks that are deployed on the patients, we can make a ready supply of oxygen from the air itself. Of course, the quality compromise is there. The oxygen cylinders from where we are taking the pure oxygen, in purity they are much higher, somewhat higher. In oxygen concentrators, we can reach from 90 to 95% of oxygen purity. But according to the doctors, for many patients, mild to moderate, that helps a lot. And mostly, oxygen concentrators are very much useful for home support whenever a patient is not in the hospital but at his or her residence. That can be easily deployed, and the breathing can be helped. Now, oxygen concentrators obviously are therefore not competitors to oxygen cylinders or high flow oxygen. These are another category that often helps the people. Now, so their technology that is required to be put in place must have some means of taking this air, and as you know, besides the gaseous components that I have mentioned, air also has got particulate matters. Alright? That's there because of the pollution. So that has to be filtered out as much as possible, and the gas is taken. From that gas, we want to separate out the nitrogen mostly and let the oxygen come out and the nitrogen be separated out. Now, for this separation, adsorption is the technology, chemical technology that is used, and there are different materials, but the material which is found to be very effective in that are zeolites. Zeolites are silicon-based material with cavities and cells which can draw the nitrogen within itself and allow the oxygen to flow. Along with such, now the details, now this is a very basic principle, but a lot of mechanical engineering has gone into it, and Professor Roy will uh, elaborate on that, uh, on the different, on the architecture and the other aspects of the thing. But in principle, we have to uh, do this, that uh, we have to separate out the nitrogen, and in our experiment we have used zeolites, and as I had said, the quality of the zeolites are very important, which will determine the performance of the concentrator, and also the availability of such systems are dependent on the supply of zeolites and other components. Besides these zeolites, there are other electronic controls and electrical uh, gadgets which push the air and perform different controls so that the purification is proper. Now we are right now still experimenting, as Professor Roy will explain. We have achieved up to 92% purity, and we expect with few more uh, iterations of experiment we'll be having a much higher purity of the thing. Now with these words, so I just wanted to differentiate the purpose of an oxygen concentrator with oxygen cylinders, and have just talked about the basic principles, the details of the engineering and the architecture, the system, what is required and why that is required will be discussed by Professor Roy. So I hand it over to Professor Roy. Thank you very much. I hope all of you will be able to gather uh, the requisite information from this lectures. Thank you very much.
Very good morning to all of you, and it is my great pleasure and proud privilege to address in the National Technology Day 2021. As Professor Basu, our director, already introduced, that we like to discuss about here a technology or technological solution on low-cost portable oxygen concentrator that we developed. So today is the day of national technology to recognize the technological innovation and their successful commercialization. So we talk about the technological aspect and its commercialization of a particular technology and thereby the product which developed by the National Institute of Technology, Durgapur, eh, which is very important in today's or the current context. So we will talk about the low-cost portable oxygen concentrator. As the Professor Basu rightly pointed out, it is not the competitor of the oxygen cylinder. Rather, it is an alternative medical oxygen sources to fight against the COVID-19. So due to the increased cases of the COVID patient due to the second wave of this pandemic, the demand of the oxygen has been increased drastically, that you know. But due to the limited resources and the logistical difficulties, oxygen is not readily available in many districts and the sub-district health facilities. And due to the second wave, there is a certain increase of demand for this oxygen, but there is a clear shortage of the supply of the oxygen cylinder in district hospital, in remote health center, in rural area. So in order to cater this, there is an alternative solution is the oxygen concentrator, and which working principle is different from the oxygen plant. Here the pressure swing absorption PSA technology is used using the molecular sieve. So, as you know, the oxygen generation methods are different types. In the oxygen plant, it is developed by the cryogenic separation in membrane technology, and also the oxygen plant, small oxygen plant, which is generally installed in the hospital and nursing home, that is by the pressure swing absorption. Along with that, our oxygen concentrator is also based on this PSA technology. Now, if you see the PSA-based oxygen generation technology, there is a vacuum pressure swing absorption or the simply pressure swing absorption PSA technology. Now, vacuum swing absorption technology is generally used in your in your hospital in a small plant. And if you see the methodology here, so it will be like this. There will be a blower through which the your air will ambient air will compressed and it will cool down and pass through the absorbent chamber. And absorbent chamber, there is a zeolite. The nitrogen is separated from the process here by this zeolite process, and the enriched oxygen will flow through this. Once the nitrogen is saturated here, the vacuum has been created, and through which the natural the nitrogen will be discharged to the air. At that particular time, the second cylinder valve will on, and the air will pass into the second cylinder, and it will absorb nitrogen and pass the oxygen in the buffer. So in this way, the continuously oxygen will generate, and by swinging from one chamber to another chamber, and then the oxygen which is kept in the buffer will flow through the different applications. So this is the method, or we can also see the another view of that. So there is a blower. So the after removing the mechanical impurities through the filter, the air will enter, the compressor entered through the cooler to the absorbent chamber, where absorbent absorb the nitrogen and and carbon dioxide, and enriched oxygen will pass through the buffer tank. So next time instant, this valve will close in first chamber, second chamber valve will open, and again second chamber zeolite chamber absorb the nitrogen, and enriched oxygen will pass through the valve. So in this way, pressure swing technology is used along with the vacuum pump, because here the output of the oxygen is 500 liter per minute, and this type of thing is generally installed into the different nursing home, different hospital oxygen plant, and through pipeline it will pass the oxygen to the patient. But our objective is to develop the indigenous portable low-cost oxygen concentrator with the two different models to cater the urgent need of the society due to the COVID-19, and mostly in the home applications. We are trying to develop the second model which can be used in the hospital as an alternative, and our objective is to make it with a low cost so that it can be affordable by the common people. And if you see the working principle of the oxygen concentrator, so here air will be in intake, and it is passes through the compressor, and from compressor, so it intake is a air. Now, as you know that here there is a approximately 78% nitrogen and approximately 20.94% of the oxygen. So technology used, I already mentioned, that pressure swing absorption technology, where nitrogen will be absorbed and the air contained enriched oxygen. Now, intake the air passes through the air filter to compressor, compressor to the heat exchanger to the two chamber, zeolite absorbent chamber or zeolite chamber, and then there will be a tank, storage tank, pressure regulator, and oxygen out. If you see the working principle of the technology behind the oxygen concentrator, the air will enter through the air filter, pass through the compressor, compress the air, and during compression it will its temperature will increase, that has to be cooled down and pass through the heat exchanger. Then the air compressed air pass through the chamber A. Say there is a zeolite, and as you know the oxygen atom size is lesser, so it will pass through this crystalline structure, but the nitrogen atom is bigger, it will remain there. And the enriched oxygen output will go to the your buffer chamber. And once it is fully saturated, then here the valve will close, the second chamber valve will open, and the air will compressor will pass through the second chamber, then chamber B, and that particular time from the A chamber nitrogen will, due to the back pressure, nitrogen will out to the air, and that time the cylinder B oxygen, enriched oxygen will produce, and it will pass to the buffer. So this way it is the pressure swing absorption technology, and through the pressure regulator we can deliver the enriched oxygen, the air with the enriched oxygen to the patient. So this is the PSA technology that we have used. So we have developed, based on this principle, based on this science, we have developed our first prototype in NIT Durgapur, and in the last year we have started working on that. And the very beginning we have in our industrial collaborator Mr. Amitra Sudan Chaudhary and Mr. Shomit Das. They continuously supported us in our development, or mostly in fabrication part, and we have tested our first prototype in our medical unit in the month of February, and we have found that the oxygen concentration, or we achieved the oxygen concentration level is 92%. And I like to demonstrate that particular technology that we have developed in our institute in collaboration with, or in support with our industrial collaborator. So this is the indigenously developed oxygen concentrator by the team of Department of Mechanical Engineering NIT Durgapur. And here, as I already mentioned, technology is the PSA, the specific grade of zeolite chamber. Zeolite is used to absorb the nitrogen, and the most of the component used here is the indigenously developed, or the developed in India. And intake is the air and the oxygen. After absorbing the nitrogen, it will come out from this, and there is a your humidifier, and through humidifier the enriched oxygen enriched air will come out to the nasal pipe. We can control the discharge or the flow rate, that means from the 1 liter per minute to the 5 liter per minute in our this particular model. And after that, we have carried out a lot of experimentation, rigorous experimentation has been carried out. And you know, any product development, there is a lot of challenges, lot of engineering inside. And we have solved that engineering for the last 2 months, and we have come up with the first commercial model, which also the up to the 5 lpm, 5 liter per minute will be flow rate. And very recently we have deployed that in the Sanjeevan Hospital of Howrah for their use for the patient, and it is now successfully helping the patient. It is an alternative solution. Those who have a mild your lung problem, for them using this oxygen concentrator even in home, it can support that particular kind of patient. And these are the product we developed, and in the name of a brand name of Pranam, and it's reaching from 90 to 94% oxygen purity. It depends on the flow rate, and mostly used for the home applications. And we are in the process of development of the 10 lpm, that means 10 liter per minute flow rate oxygen concentrator, which is mostly used in the hospital applications. And during our development stage, there are glimpses of that. So we have developed the CAD model. After that, we have system integrations. So, and initially, you know that any technology development or ultimately the product development, there are a lot of engineering challenges. We also face that one. Initially, in the very beginning, we achieve up to the 85.4% or 85.5% oxygen concentration, and after that we have solved our engineering issues. After solving that one, we have improved upon that efficiency, and ultimately we reach around 92% oxygen concentration in our second model. And in your low LPM, that means in 2 LPM we are getting 94% of oxygen concentration. So as you mentioned, this will be the low cost oxygen concentrator. So obviously cost is very important, it should be affordable. So the manufacturing cost for the first model, where the flow rate is up to 5 lpm, is around 28,000. So, and we are in the process of development of the model 2, where the flow rate is increased up to 10 lpm, and that cost, manufacturing cost, become approximately 40,000. So it's if we can commercially, we are in the process of commercialization, and obviously when we can develop in a mass scale, the cost will reduce significantly. So with this, we hope that the technology developed by NIT Durgapur in collaboration with our industrial collaborator can help our society in these critical pandemic situations. With this hope, I like to thank all of you and wish you a very happy National Technology Day. Thank you for your kind patience.